Good morning, students. Today we will discuss about the topic spread spectrum. Okay. So what is spread spectrum? It is an attempt to increase the bandwidth of the actual message signal. Okay. So what is spread spectrum? SS aims to increase the bandwidth of message signal. Okay, that means we are trying to increase the channel capacity. Okay, so how it is done? Through a different code, or we can say a different signal, that is a random signal. We call pseudo random generator. PRG, pseudo random generator. So this is random in nature. So how to increase the bandwidth? By adding a pseudo random generator signals, which is a random natured signal. We add it to increase the bandwidth. Okay. So suppose the graph looks like this. So this is frequency, this is randomness. Suppose this is the bandwidth. What is bandwidth here? Bandwidth of original signal is equal to f2 minus f1. Suppose this is f2 minus f1. This is the frequency at the end. This is the frequency at the start. This is the range of frequency, we can say, in which our original function is original message is functioning. Okay, so this is the bandwidth of the original signal. Now what spread spectrum do is it works like something like this. It increases the frequency range, that is it increases the bandwidth. So what is the bandwidth? Suppose this is f0, this is f3. So what is the bandwidth of the spread spectrum? It is f3 minus f0, which will be obviously greater. So BSS is definitely greater than B original. Okay. So this is achieved how? By adding some other signals. Okay, which are extremely random in nature. We call it pseudo random generator. Okay. So this is called spread spectrum technique. Now you may ask, ma'am, why do we need it? Why do we need a spread spectrum technique first of all? What is the necessity of it? This is done because it is done because of various reasons. Okay, there are multiple reasons for doing this. So number one is it gives us security. Okay, how come security is achieved? See, suppose your signal channel is this. Bandwidth means capacity of after all. How many numbers of bit per second is transmitted? That is what we call essentially bandwidth. Okay. Now, suppose this is the original bandwidth. Now, what are we doing? We are adding some signals, isn't it? Random signals, pseudo random generator, and we are increasing the capacity to BSS. Now, due to the randomness, it is very much secure because at the center side, the center does spread spectrum, that is through the pseudo random generator, which is a code. Essentially, it's a code. Okay. So generally, what we use is it is type of a key. So we are encoding the signal. Okay. The signal is encoded. So encoded signal is being transmitted. So in the internet, even though since internet is very unreliable, anything can happen now. The signal may get changed, the signal, someone may attack, someone may try to intercept it and read it. So for that matter, if encoding is done, decoding cannot be done by any other third party. The receiver will only know how to apply the pseudo-random generator. It is like a key that is between the sender and receiver. So only receiver knows the pseudo-random generator and it can decode the encoded signal and it may get the original signal. Okay, this is receiver side. So this is what happens usually through the pseudo-random. It acts as a protective layer. Okay, this pseudo-random generator acts as a protective layer. So that's why it is very much secure. Okay, so security is one reason why we use spread spectrum. Okay, now second thing is interference. Okay, so what is the second thing? Interference. No one can interfere. Okay, there is no other signal interference because it is so random in nature that any other randomness wouldn't affect the original signal. See, it is secure. Now this is the random signal. Now any other randomness wouldn't add to all the code. Through the pseudo random code we can decode it. Third thing is it is immune to distortion. Because of the pseudo-random generator, no one can distort it. Only receiver has the code, so it is totally protected. The receiver can use the pseudo-random generator to decode it. Okay, it cannot be distorted in any way. Okay, because the inner bandwidth only has the message. Spread spectrum is using as a protective layer. So any interference will be taken by the pseudo-random generated signal. That is very random in nature. That's why it takes all the drawbacks. Anything doesn't affect the inner bandwidth signal. Okay. So that's why it is immune to distortion. Okay. So this was about spread spectrum. Now spread spectrum is of two types essentially. Okay. We can classify spread spectrum into two types. One is direct spread spectrum, DSS. What is it? Direct sequence spectrum, DSSS. Direct sequence spread spectrum. Second one is FHSS, frequency hopping spread spectrum. Okay. So spread spectrum consists of two types. It has two variants. One method is direct sequence spread spectrum. Second one is frequency hopping spread spectrum. Now what happens? What is the difference between these two? In direct sequence spread spectrum, exactly whatever I said, that is what is the variant of direct sequence spread spectrum. What happens is we increase the bandwidth by using a pseudo-random generator. Here we use code division multiple access, CDMA. You have already studied. That is, encoding is done. Encoding of signal is done. And at the receiver side, signal is decoded. It is very well secure. That is what is direct sequence spread spectrum. Now, FSSS is a bit different. FHSS, what it focuses on is frequency hopping. Okay, it uses two types: time division multiple access, okay, and frequency division multiple access. Here, what happens is time and frequency are of importance here. Here, the sender and receiver, sender side, suppose receiver side. Sender and receiver side hop between various different frequencies at random or specific, it can be random or specific intervals. So what this focuses on is here sender and receiver. So here in FHSS what happens is the there is frequency hopping. Frequency hopping means change in frequency. The frequency in which the signal is sent is changing, both in case of sender and receiver. How the frequency changes as per the frequency division multiple access. At what time? Using the time division multiplexer. So time is decided by DDMA, frequency is decided by FDMA. So both these are used in frequency hopping spectrum. And what happens? The sender and receiver always change the signal frequency at multiple interval of time. Okay, so this is what happens. So basically the bandwidth is enhanced and they work at multiple frequency at various time. Okay, at T1 maybe the sender is at frequency F1. Okay, and at the same time at T1 only receiver may be working at the frequency of F2. Okay, some different frequency. So all you need to remember is in frequency hopping spectrum there is change in frequency at certain interval of time. It usually uses TDMA and FDMA to get its job done. This way the bandwidth is enhanced since there is variable frequency. The frequency range is more. That's what is bandwidth. Bandwidth is the difference between frequencies. As I mentioned few minutes back, what is bandwidth? Bandwidth means difference between frequency. If the variation is more, if they are changing frequency, the bandwidth increases. This is what spectrum is. So this is the type of frequency hopping spectrum. It uses what? TDMA and FDMA. So we more or less discuss the entirety of spectrum, and in the next class we will continue with medium access control topic. Okay, how in a common channel, in a common medium, multiple station send data, that is they transmit data and receive data, how it is done, how the medium is accessed, that we will discuss in the next class. If you have any doubt, you can reach me through WhatsApp or you can post it in the comment section. I will reply. Okay. Thank you.